everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about CPU scheduling algorithms. In that, we have discussed about first come, first serve. Today, we are going to see about shortest job first CPU scheduling algorithm. So, overview of the presentation. In this SJF scheduling algorithm, we are going to see two methods. What are they? Preemptive and non-preemptive. So, let us see the definition of SJF CPU scheduling algorithm. So, the shortest job first or shortest job next is a scheduling policy that selects the waiting process with the smallest execution time. So, with the smallest execution time to execute next. So, with the smallest burst time that will be executed next. So, it is also known as shortest job next. That is nothing but SJN. And it can be in both methods, preemptive and non-preemptive. This is what about SJF. So, let us see the characteristics of SJF scheduling. So, shortest job first has the advantage of minimum average waiting time among all other scheduling algorithms. So, it has one of the advantage with a minimum average waiting time among all the different scheduling algorithms. And it is a greedy algorithm. It may cause starvation if shorter processes keep coming. So, if it causes some starvation because the processes keep on coming. And this problem can be solved using the concept of aging. So, this can be solved by the concept of aging, but minimum age will be executed first. It is practically infeasible as operating system may not know the burst time. So, it is sometimes infeasible and they don't know about the burst time. Therefore, may not sort them. So, they cannot be sorted. While if it is not possible to predict the execution time, several methods can be used to estimate the execution time for a job. So, if the prediction is not possible, we can solve with several methods for solving with the estimation of the execution time of a job, such as weighted average of previous execution times. So, we need to calculate the weighted average of previous execution times. SJF can be used in specialized environments where accurate estimates of running time are available. So, it is having some special environments where they can estimate the running times which are available. So, let us see the algorithm for the SJF. Sort all the process according to the arrival time. So, we need to sort each and every process with their arrival times. So, then select that process which is having arrival time minimum and minimum of burst time. We need to select the process which is having minimum of arrival time and minimum of burst time. And after completion of the process, make a pool of processes that arrives afterwards till the completion of previous process. So, till the completion of the previous one, no other process can enter. Why? Because until and unless the execution completes only, the next process can enter. That is what about SJF. So, about of the previous process and select that process among the pool which is having minimum burst time. So, we need to select which is having minimum burst time that will be executed first. So, we need to select from the pool which is having the minimum of burst time. So, let us see our non-preemptive method for SJF. So, in non-preemptive SJF, a process which has the shortest burst time is scheduled first. So, what we have said, which is having the minimum of burst time that will be executed first. If two processes have the same burst time, then we need to apply FCFS to break that time. Suppose P1, P2 arrivals at 1, 2 with the same burst time of 3, 3. So, which will be executed first? So, to break this tie, we need to apply first come, first serve. So, P1 will be executed first. Why? Because we are applying first come, first serve. So, the process which comes first will be executed first. So, let us see the example problem. So, consider the following table which can have arrival time, burst time of 5 processes P1 to P5. So, based on this burst time and arrival times, we need to solve in SJF in non-preemptive mode. So, let us start our problem. So, process arrival time, burst time, completion time, turnaround time and waiting time. So we need to solve this. So P1, P2, P3, P4, P5. So what are the arrival times? 25104. So 25104. Next burst time 62834. So 62834. So based on the burst time and arrival times, we need to solve our Gantt chart. So what is Gantt chart? The processes under execution is known as Gantt chart. So what is ready queue? The processes which are waiting for the CPU is known as ready queue. So at the time arrival time 0, which process is ready for the execution? P4. So our Gantt chart starts from 0 and which process is ready? P4 with the burst time 3. So 0 to 3, which processors are ready? So P4 is completed. So next P1 is ready, P3 is ready. So we need to check only 0 to 3, whatever available in arrival times. So P1 is available and P3 is available. So in this, what is our algorithm? SJF. So the burst time which is having minimum value, that will be executed first. So which is having P1 or P3? So P1 is having minimum burst time. Next is P3. So P1 with the burst time is how much? 6. So 6 plus 3 is 9. Next 0 to 9, which processors are available now? P2 and P5. So who is having minimum of burst time? P2. So P2, then after P5. So P2 after P5. Why? Because P2 is having minimum value of burst time 2 and P5 is having the minimum value of 4. So next, which is waiting for the CPU? P3 is waiting with the burst time 8. So 8 plus 9 how much? 17. Next, which process is waiting for the CPU? P2. So take P2 with the burst time 2. So 17 plus 2 is 19. Next, what is left? P5 is left with the burst time 4. So 19 plus 4 is 23. So this is our Gantt chart. So now we need to do our completion time, turnaround time and waiting time. So in the first process, P1 completes its execution by 9. So completion time is 9. Next, P2 is completed by the completion time of 19. Next, P3 is completed by 17. Next, P4 is completed by 3. Next, P5 is completed by 23. So now we need to find out the turnaround time. What is the turnaround time formula? CT minus AT. So completion time minus arrival time. So 9 minus 2 is 7. 19 minus 5 is 14. Next 17 minus 1 is 16. 3 minus 0 is 3. 23 minus 4 is 19. Next, what is the waiting time? Turnaround time minus burst time. So what is turnaround time? Turnaround time minus burst time. So 7 minus 6 is 1. 14 minus 2 is 12. 16 minus 8 is 8. 3 minus 3 is 0. 19 minus 4 is 15. So this is what about turnaround time and waiting time. So now I need to calculate the average of waiting time. What is the average of waiting time formula? Total of waiting time by number of processes. So what is total of waiting time? 13. 13 plus 8 is so 21. 21 plus 15, so 36. So 36 divided by 5. So number of processes are 5. 5 ones are 5, 5 sevens are 35. Remaining is 1. So 0.1. 1 is remaining 10. 5 twos are 10. So 7.2. So average of waiting time is 7.2. This is what about SJF in non-preemptive method. So let us start our SJF method in preemptive mode. In SJF preemptive mode scheduling algorithms, jobs are put into ready queue as they arrive. Which are arriving, they are kept under ready queue. But as a process with shortest burst time arrives, the existing process is preempted or removed from execution and the shorter job is executed next or executed first. So, whenever we are taking as, suppose we are taking burst time 6 and the given time quantum is 2. So, for the burst time 6, we need to preempt the value of 2. So, 6 minus 2 is remaining 4. Whatever the values which are having can be preempted or removed from the execution. That is what about preemptive method of SJF. Consider the following table of arrival time, burst time and the 5 processes. So, with these 5 processes, we need to find out our preemptive method for the shortest job first. So, let us start our problem. So, process arrival time, burst time, completion time, turnaround time and waiting time. So, we need to take all the 5 processes P1, P2, P3, P4, P5 and the arrival times 25104. The burst time 62834. So, for this we need to find out our ready queue and Gantt chart. So, Gantt chart, as you know, we starts from 0. So, here I am taking for this time quantum as 2. So, for this time quantum, we need to deduct or preempt the value of burst times with the time quantum 2. So, starting with our Gantt chart, the arrival times will starts from 0, which is ready for the execution. P4 is ready. So, P4 is waiting for CPU. So, take P4. What is the burst time of P4? 3. So, we need to do minus. So, 3 minus 2 remaining is 1. So, we need to deduct or preempt the value of 3 minus 2. So, 0 to 2. So, now check 0 to 2 which are ready for the execution. So, P4 is ready, P1 is ready, and P3 is ready. So, which is having low burst time? P1. So, P1, then after P3, then after P4. So, already P4 is existing. So, we need to write after the process next. So, P1 with the burst time is how much? 6. So, 6 minus 2 is remaining is 4. So, P1. So, 0 to 2 plus 2 is 4. So, now 0 to 4, now check which processes are ready? P5, P4, P3, P1. So, which is having low burst time? P4 is existing. So, we need to write next value is P2 and P1 and P5 is having same burst time. So, which one we need to take at this time? We need to apply first come first serve. So, we need to write P1 first, then after P5. Next, P1 is completed. Who is waiting for the CPU? P3. So, P3's burst time is how much? 8. 8 minus 2 remaining is 6. So, 2 plus 4 is 6. So, now P3 is also completed. Now, 0 to 6, now all the processes are available. So, take it as P2. Okay. Next, P4 is ready for the execution with the burst time 1. So, P4 totally completes its execution. 6 plus 1 is 7. So, next, which process is waiting for CPU? P2 with the burst time is 2. This also completes its execution. P2. 7 plus 2 is 9. Next, which process is waiting? P1 is waiting. So, P1 with the burst time 4. So, remaining is 2. So, 9 plus 2 is 11. So, next P5 is waiting. So, P5 with the burst time 4. So, 2 is remaining. So 11 plus 2 is 13. So next, which is waiting? Already P2 completed, so we need not take. So what are remaining now? P1, P3, P5. So P1, which is having low burst time, again P1, next P5, then P3. So what is the value of P1? So 2. So now it completes its execution. P1, 13 plus 2 is 15. So next, which process is waiting? P5 is waiting. With the burst time 2. This also completes its execution. So 15 plus 2 is 17. So P3 is remaining. So P3 direct take the value 6. Why? Because no other processes are waiting. So 17 plus 6 is how much? 12, 13, then 2. So 23. This is our Gantt chart. So now we need to complete our completion time, turnaround time and waiting time. So P1, when it is completed its execution at 15. So 15. Next, P2 completes its execution at 9. Next, P3 completes its execution at 23. Next, P4 completed its execution at 7. Next, P5 completes its execution at 17. This is what our completion time. So turnaround time formula is CT minus AT. So CT, 15 minus 2 is 13. 9 minus 5 is 4. 23 minus 1 is 22. 7 minus 0 is 7. 17 minus 4 is 13. So next, 13 minus 6 is 7. 4 minus 2 is 2. 22 minus 8 is 14. 7 minus 3 is 4. 13 minus 4 is 9. So this is what about turnaround time and waiting time. So now we need to calculate the average of waiting time. What is the average of waiting time? Total waiting time by number of processes. So 36 by 5. So 5 ones are 5 sevens are 35. 1 is remaining. 0.1. 2s are 10. So 7.2% is the waiting time of this preemptive SJF. Today we have discussed about SJF CPU scheduling algorithm. And in this we have discussed about preemptive method and non-preemptive method. So in the next session we are going to see about priority scheduling algorithms. So if you have any doubts you can comment. Thank you.